Hello everyone. For this week's tutorial, I'd like to discuss vector addition and vector subtraction. Surprisingly, once you understand vector basics as discussed in the previous week, it is very easy to add and subtract them, just like adding and subtracting regular one-dimensional numbers. This is because if you wrote the vectors down in arithmetic form, it would look like this. With all the dimensions listed separately. The arithmetic notation of vectors is very easy to visualize addition, because once a vector is in this form, you simply add the components individually, like this. And graphically, it would look something like this. If the x and y components, however, were different from each other and did not neatly line up like this, it would look very different. Example. Similarly, subtraction would use the same principles, just subtracting instead of adding. And just like with how subtraction works with regular numbers, subtraction is merely the opposite of addition and is also order sensitive. So depending on which part goes before the minus sign and which part goes after, you will get different results. Although the only difference is whether there is a negative sign before your result or not, you will have the same quantity otherwise. Like so. As you can see, Vector addition and subtraction, if expressed in arithmetic form rather than graphically, is very easy to understand and works very similar to one-dimensional addition and subtraction, with you simply adding and subtracting the individual components. The conventional notation for vectors in arithmetic form, however, is not x and y, like I wrote here, but instead I and j, as these are based off a familiar concept from algebra class called complex numbers, which use I as the imaginary number. Similarly, a 3D vector with a z component would have its z component called k rather than z. And the formal term for this type of expression is a vector in rectangular or Cartesian form, which is what I'll be discussing more in depth next week, Cartesian versus polar form of vectors, and how you can express the same exact vector in two very different ways.